Hello my dear students, I am Divyam and I am welcoming you all in another video. In this video, we are going to discuss very quickly the important questions which can be asked from this chapter. We will divide this chapter in two types of questions. One is theoretical and one is numerical. So in this video, we will discuss the theoretical questions which is straightforward from the syllabus. Here you can see the syllabus of your chapter thermodynamics. So let's understand what all the straightforward question which you can see directly from the syllabus. The very first question which can be asked from this chapter, because we will go from straightforward questions to the complex question. So straightforward question means the direct theoretical questions which can be asked. So very first question you can see from here from the syllabus is that the extensive and intensive property. So the question can be asked that what do you mean by extensive and intensive property? Give examples. All right. The next question can be asked what that define state function or state variable and give example. This can be asked in 2 marks or 1 marks question. The next question which can be asked is define or state the first law of thermodynamics with the relations. Okay, and this is also a very because earlier this part was not very much important because lots of things were there, but now if you see that measurement of delta H and delta U, enthalpy and internal energy, this is also a very much focused part, and one question can be asked from this topic also, that how you will measure delta H and delta U, because in NCERT you will see this is very clearly discussed, and this diagram of setup is also there in your NCERT. So this question can be asked directly, that how you measure delta H and delta U. The next question is also a very straightforward question, that state the Hess law with example. This is also discussed and mentioned in your NCERT very well. Now there are lot many small topics in which we calculate the enthalpy of particular reaction. Like if the reaction involved bond dissociation, so we calculate bond dissociation enthalpy. If there is combustion is taking place, so we calculate the enthalpy related to combustion. If any formation is happening, so we calculate enthalpy of formation, atomization, sublimation, phase transition, ionization, solution, dilution. So from this topic, how the question is going to ask, so you need to know that the here also a straightforward question can be asked, that explain the explain the enthalpy of combustion, or explain the enthalpy of sublimation, explain the enthalpy of solution. Only this type of question can be asked from this topic. Okay, so you have to learn the definition of like bond dissociation enthalpy, combustion, enthalpy of combustion, enthalpy of formation. You have to learn the definition and any one example related to that topic. Okay. Now here also a very straight question, that define or state the second law of thermodynamics, because it's written briefly in your syllabus. So briefly means you have to know the statement and the relation, if there any relation. Okay. Now what do you mean by entropy? Define entropy, how the entropy increases or decreases, how the entropy dependent on the phase changes. If the phase changes, like if solid, liquid and gas, so which is having more entropy, this type of concept can be asked. And here also a Gibbs energy for spontaneous and non-spontaneous. So one question can be asked, that what is the relation between Gibbs free energy and spontaneity? Gibbs free energy means delta G, and spontaneity, what is the relation between these two? So this is also explained with a table in your NCERT very clearly. Okay. And what is the criteria for equilibrium? Means if there is an equilibrium reaction, what is the value of delta G or delta S or delta H? this is all related with the Gibbs energy relation. Okay, and the last question is also state the third law of thermodynamics. This is also written this very briefly, so no need to worry. The question will be asked like state the third law of thermodynamics with relation, or only 1 marks or 2 marks question can be asked. So if you see the overall syllabus of your thermodynamics chapter, lots of questions are very straightforward, and this chapter comes with the value of 5 marks only. In this 5 marks, one question will the partition will be like 3 plus 2, and one question will be numerical and one is theoretical. So numerical questions is of 2 marks and the theoretical question asked will be of 3 marks. So very important questions are here, that I will repeat once again, that what is extensive intensive property, define state function, state the first law of thermodynamics, measurement of delta H delta U, what is do you mean by Hess law, what is enthalpy of combustion or enthalpy of bond dissociation, state the second law of thermodynamics, what is the relation between Gibbs energy and spontaneity, and or what is third law of thermodynamics. So let's start with the very few questions today in this video, and further I'll make another video for numericals also. So the very first question is, write down the statement of first law of thermodynamics. If this is your question, so you have to give the statement and also the relation which is given by first law of thermodynamics. So you can see here it's written that first law of thermodynamics involves both the heat and work relation with the internal energy. So the relation is delta U is equals to Q plus W. This is the first law of thermodynamics relation. And what is the statement? The statement is the energy of an isolated system is constant, or you can also state it like that the law of conservation of energy. Okay, and what is the little bit if you explain this particular relation, you have to write like delta U is dependent only on initial and final state, also delta U independent of the way the change is carried out, and this is the explanation of delta U. Okay, if there is no transfer of energy, let's say if Q is 0, if there is no transfer of energy or as work, that system is known as isolated system. If Q is also 0 and W is also 0, let's say if we have any isolated system, so Q and W both are 0, so delta U will also equal to 0. This is the condition of isolated system. Sometimes the question is also asked like that, if you have an isolated system, what will be the value of delta U, or can be asked with the relation like what will be the value of delta H or delta S. So you have to relate these concepts with one another. So if there is an isolated system, delta U is 0 because Q and W both are 0. Okay, now let's move on to the next question. What do you mean by the state variable or state function? Give examples. So there are some of the variables. Variables means which changes with the state. Variables which variate in their values. So there are a lot of properties which are state variables. It means if the state changes, that also keep on changing. So there are lots of properties like internal energy, enthalpy, entropy, Gibbs energy, pressure, temperature, volume, mass. These all properties are state function because they depend on the state. Okay, the initial and the final state. Some of the values, some of the properties are path function also, work and heat. These depend on the path. It means how you achieve the reaction, that variates some of the property like work and heat. So these are what path functions, and some properties depend on the state, that where we start and where we end only. So they are known as state functions. Let's move on our next question. The next question is, explain extensive and intensive property with example. So extensive property are those properties whose value depends on the quantity or size of matter which is present in system. So the examples are mass, volume, internal energy, enthalpy, heat capacity. You have to learn the examples very carefully, that no mismatch should be there. Okay, you have to very clear that you are not writing the intensive property example in the extensive property. Okay, so do learn one or two property, but very carefully. Intensive properties are those which do not depend on the quantity or size of matter present. What they want to say, that if there is a, let's say any system is there, okay, and we are having some gas in the system, and if we do a partition in the system. So if we do the partition in the system, let's say before partition the temperature was T and the volume was V. But after partition, we will get volume half in both the sides, but the temperature remains same. So temperature is not depend on the particles present. So the temperature is independent. Okay. So the temperature is independent. So the temperature is intensive property, but the volume is dependent on the particle or mass, you can say. So the volume is extensive property. Okay, a very small trick to learn, that intensive start from in and independent also starts from in. So whatever the property is independent of the size and matter are known as intensive property, and the rest is known as extensive property. All right. Now let's move on the another question, ours important question, that explain the steps taken in the measurement of delta U and delta H. Draw diagram of setup. So here you can see two partitions. We will start from the inside partition, that this is the steel vessel. Okay, this is a steel vessel. We call it as bob. In this steel vessel, there is a sample. This sample is combustible sample. We can burn it. Okay, and to burn this sample, lids here. Two firing lids are attached to the sample. One oxygen inlet is here. From here, oxygen will be pushed inside, and okay, so firing lid, oxygen inlet, and sample is present inside the steel vessel. Okay, around the steel vessel there is a water bath. In this water bath, one thermometer is attached and one stirrer is here. Okay, I hope the picture is very much clear. One is steel vessel, and besides steel vessel we have water bath with one thermometer and one stirrer, and inside the steel vessel we have a firing leads, oxygen inlet, and the sample. When we burn the sample, the heat transferred from inside to the outside in the water, and this temperature change or heat change is monitored by the thermometer. This is only about the delta U measurement. This is the diagram through which we can measure delta U. Okay, the note will be available in the PDF form. I will attach with the video. You can download from there also. And this is how the heat evolved during the reaction transferred to the water around the bomb and its temperature is monitored. This is how we can calculate delta U. And for delta H, same, this is known as calorimetry. Calorimeter, the reaction mixture is present in this container, a thermometer is attached, and the measurement of heat change at constant pressure can be done by using calorimeter. We know delta H is equals to QP, the heat change under pressure, means heat absorbed or evolved. QP at a constant pressure is also called as heat of a reaction or enthalpy of a reaction. So delta H is equals to QP, the enthalpy change under constant pressure. Okay, and here the constant pressure is the atmospheric pressure because the system is open system. Here we are taking system as open system, and the pressure which is constant is atmospheric pressure. It is in an exothermic, the heat evolved and the system loses heat to the surrounding, so QP will be negative. This already I have discussed. When the exothermic reaction, QP is negative, and if there is an endothermic reaction, the QP is positive. So this is how you will write your answer. You have to draw the diagram and you have to write the way of measuring the temperature change. So in which in delta U, we do the delta U is equals to QV, means at constant volume we observe the heat change, and for delta H we calculate the heat change under constant pressure. Alright, let's move on to the next question. The next question is, give statement of that the entropy of the universe is always increases in case of every spontaneous or natural process. What does this mean? That if there is any reaction is happening by its own, it means if the reaction is spontaneous, entropy will always increases. Okay, but for equilibrium, entropy is 0. For spontaneous, delta S is always positive, and if there is a negative value of delta S, the reaction will be a non-spontaneous also, or can be a spontaneous also. This will depend on the, if negative value is coming, then we will see what is the value of temperature, and if temperature is low or high, how it affects the spontaneity of the reaction. We will discuss that also. So because we have to give a very brief because we have to give very because we have to study it very briefly, so we are not going in detail part. It will definitely comes in 1 or 2 marks question, in which you have to write the relation and the statement only. Let's move on to the next question. The next question, explain relation between Gibbs energy and spontaneity. A very good question, and you can answer or give the answer from here, that delta G is equals to delta H minus D delta S. This is the Gibbs energy related to the enthalpy and entropy, and from here you can give the relation of the Gibbs free energy and spontaneity, that how the temperature, entropy, enthalpy affects the spontaneity of the reaction. So the question is, explain the relation between Gibbs free energy and spontaneity. So we have to explain it a little bit more. That here the criteria of spontaneity at constant pressure and temperature. If delta G is negative, if the delta G value is coming out to be negative, the process is spontaneous. And if delta G is positive, the process is non-spontaneous. We have the relation delta G is equals to delta H minus T delta S. So if the value we get here is negative, then this reaction is spontaneous, will occur by its own, and if the delta J is positive, the reaction is non-spontaneous. One table is given in decreased temperature. It's very well given, and already I have discussed in the class also. This is the table. I cannot show from, this is the table. Okay, this is the table which is related to this question, and you have to understand that. If you have any doubt, give a comment in the comment section. I will discuss this table also if you have any doubt. All right, now the last question is it's not the last question, second last question. Explain the enthalpy. See, if we have to explain the enthalpy of formation, all right, the question is enthalpy, explain enthalpy of formation. You have to write the, first of all, the statement, and then the example, different example, and if you have any kind of formula related to that. All right, so the expression, the statement, formula, and example. Okay, enthalpy change of formation of a 1 mole of a compound from its elemental state in their most stable state of aggregation is called the standard molar enthalpy of formation. This is represented by delta F H naught. Okay, these are the stable state, because in this we have to keep all the molecule in their standard state. So I have given you that some of the elemental form in which this exist, like Br2 always exists as liquid, I2 is solid, sodium as solid. So you have to learn this table, and this will help in the calculation of several examples. Okay, and here you can see the examples, and this is the relation. Okay, for formation I have written, I had compared formation and combustion part. So this is the way how you attempt this question. The question can be asked like, explain the enthalpy of bond dissociation energy, explain the enthalpy of atomization. So there are several questions, but here I had just shown you one example. Okay, one more question is asked that state the Hess law. Okay, if the question is asked about the Hess law, so you have to give the statement first and then example. The statement says that if a reaction takes place in several steps, then its standard reaction enthalpy is the sum of the standard enthalpies of the intermediate into which the overall reaction may be divided at the same temperature. What they want to say, that if a reaction takes place, let's from A converting into B, and the enthalpy of reaction delta RH is this, and if the same conversion is taken in through various steps, so sum of these steps is equal to this one step. Here you can see delta RH is equals to delta RH1, H2, H3. This is the Hess law. Okay, in the statement also you can see it's written that the intermediate into which the overall reaction may be divided at the same temperature, okay, is the sum of the standard enthalpy. All right, you also have to give one example to support your answer. Okay, this example I have taken from your NCERT. You can read and you can understand. If you have any doubt, you can ask me in the comment section. So this is all about the today's topic. We have taken several questions which is theoretical. Okay, in another video, if I make some of the, I will take some of the numericals from this chapter, and we will discuss that. So a very precise suggestion for you all is that if you start any of the chapter, just first of all see the syllabus and divide the syllabus into various form, like theoretical questions, numericals, or easy one, direct question, that, and start from the very basic thing. So thank you so much for watching my video. Just like, subscribe and share also. If you like my video, then do share with your friends and families. Thank you so much.